Let's see. Today, we are starting with algebraic equations. So up until now, we have been doing algebraic expressions, okay? So an equation is a mathematical statement containing expressions and an equal sign. So if you see this word equation and equal sign, okay, so if you see an equal sign, it is no longer an expression. We are now talking about an equation. I am probably going to take my video off so that I can write. You guys will forgive me if you want to see my pretty face. Sorry, not today. Try again another day. There we go. So in equations, numbers may be represented by an unknown variable such as x. Okay, what's important to note is that we don't only use x. I know a lot of my learners, when they start seeing like y and m and other variables being used, and they start freaking out because they're like, what is that? So remember, we don't only use x, we use x very often, but others can be used as well. Okay, to solve an equation, the value of these variables must be found. So an example of an equation would be 2x minus 4 equals 5. Okay, we have an expression on the left. We have an expression on the right. I know it's one, but it's a monomial, let's not forget. And we have an equal sign. So that would be our equation. So let's talk about important vocabulary that we need to know. Okay? Addition. When we are talking about addition, i.e. when you have number sums or you're trying to interpret an equation, addition is associated with the following words. So we are over here for anyone who might be lost. Okay, if I say something plus something, or an apples and bananas, that would be adding them, or the total of, or the dogs and cats all together, increased by, some, more than, added to, make, combined. All of these are associated with the addition symbol. Okay, next we have subtraction. Okay, so if you're reading a sentence or you would like to interpret a sentence, you will say this subtracts that, or if you take away this, or if you decreased, fewer than, less than, minus, difference. All of those are associated with subtraction. Okay, and then we have multiplication. Multiplication, we use words like double something, triple something, okay? Let me use green. So for multiplication, we use words like we double something, we triple. And the important one is also off. If I say 2% off this, then we all know off sums have to do with multiplication, okay? So these words are very important to know, guys, very important to know. Division, the words that are associated with division are quotient, per, ratio, divided by, divisor, divided into, split up. Those are all associated with divide. Then we have our last ones, equal. I'll go up just now for screenshots. So we have equals and parentheses, okay? Equals literally means that this is equal to this, or that is that, okay? Parentheses are used for basically when you want to get in the way of odd maths, okay? So when you look at this, twice the sum of, so if I say twice the sum of x and y, if I don't add brackets there, then I'm going to end up multiplying 2 times x, which is not what I want. I want twice the sum. So those brackets will force you to first add and then double, okay? Someone wanted to take a screenshot of addition and subtraction, I'm guessing. I'm going to leave it here for a couple of seconds. So far, I feel like we're all fine, okay? Today's lesson is not that much pressure. Oh, speaking of pressure, quizzes. I'm very sorry, guys. I was not able to get your quiz results, okay? I promise you I'll try to get them as soon as possible and my leaderboard will be up. Okay, cool. Now, let's go and interpret algebraic equations. Okay, so there are a number of ways you can interpret algebraic equations, okay? So I'm gonna start with, nope, where's that going? Wrong place, not going on. So I'm gonna interpret the first one for us, just to show you the standard and what I expect you guys to say when we are doing this. I know this might seem very tedious to some of you, but if you learn how to interpret them, then you will learn how to form algebraic equations. Okay, so for the first one, I will say twice an unknown number decreased by 20 is 100. Okay, so that's my interpretation of this algebraic equation. Let me make it a bit bigger for us. There we go. So this is how I expect you guys to interpret such equations. Okay, so obviously there's a number of ways in which you could have interpreted this. You could have said 2 times a certain number, or double a certain number, or, you know, like there's a lot. The point is you need to make sure you include each and every aspect of this. So let's check. Twice, nope, twice, which is 2 times. Okay, that's what twice means, or double. So twice an unknown number. So that would be my X. I'm just color coding so that you see what I'm doing. Decreased by 20. That's our minus 20. And the last part is 100 equals 100. Easy enough, right? Yes, that's what we're doing. Tato, that's what we are doing. We are writing it in words. I know Minanche load shedding has us all by the ears. I don't like it. It's depressing me. Who's going to write the next one in words for me? The one that's already on the screen right now. Itumeleng. Let's hear what Itumeleng has to say.
Hi, ma'am.
Hello.
So it's going to be an unknown number double. And
what does double mean?
Sorry, an unknown number twice.
That's still times 2. What are we doing to the unknown number?
We're going to multiply it
by what?
By 2.
What does x squared mean?
And it's x squared twice.
Squared. So an unknown number squared. See, guys, we need to both vocabulary. That little 2 at the top means squared, right? Okay, continue.
Yes, an unknown number squared increased by 5 is 20 decreased by an unknown number.
Decreased by an unknown number. That's what you say, right?
Yes, ma'am.
Let's check our statement. Let's check our statement. The only thing I'll say about the statement is, do you see that we are using the same unknown number on both sides? Oh, that's lightning, guys. Don't mind that sound. We have very bad lightning here. And thunder. Do you see that we're using the same one? So how will you make sure that people know that this number, this unknown number, is the same one as this unknown number?
Ma'am?
How would you make sure that people know that that unknown number is the same one as the one on the right? Because it's x and x, right?
Yes, ma'am.
So how would you do that? What words would you use to make sure that people know that our unknown numbers are the same?
Maybe I will say that it doesn't have any number, and the first one is squared, and the second one doesn't even have a number.
That's true, but you can say an unknown number squared increased by 5 is 20 decreased by the same unknown number. Do you see what I did there?
Yes, ma'am. Yes, ma'am. I see.
Makes sense, right, Dumile?
Yes, ma'am. It makes sense.
So all you had to do was to say by the same unknown number. Otherwise, how do I know if it's two different unknown numbers? I wouldn't know, right?
Oh, okay, ma'am. I get you. I get you.
So if you want to make sure that we use X, then you need to say so. So we have an unknown number squared, which is what we have there. Okay, no. Let me make our little highlights nicely. Thanks, Itubele. I appreciate your help. I'm
Thank
just
you,
going to
ma'am.
color code our sentences here. Okay, so an unknown number, X squared. That's our little tool over there. Increase by 5 plus 5 is just the area equals to 20, actually is 20, can be one thing. Decreased by the same unknown number. So I'm using the same color because you are decreasing by the same X that you squared on the left-hand side. Okay, guys, we are with me. Okay, who's next? We still have more to do. Excuse me, who's going to interpret this one for me? Tato's hand just went up. Nope, Tato's went vanished. Manuel?
Okay, ma'am. So we're gonna say an unknown number cubed is the square root of twice the unknown number increased by 3.
Of twice the unknown number. Did you say increased? Increased
Yes.
by 3. Thank you very much. That was beautiful.
No problem.
That was beautiful. Okay, let's check, guys, what we have here. I saw in the chat someone said, in school, we say plus or minus. That's fine, but then you're not interpreting it. You're just telling me what you see. Okay, you're just telling me what you see. I want you guys to interpret it. Because plus is like saying 2 plus 5. You know, you're just telling me what you see. You see a 2, you see a plus, and you see a 5. But if your teacher doesn't mind it, then that's okay. But I just wanted us to learn to interpret it and tell a story. Guys, remember I said this isn't necessarily important for assessment purposes, but if you cannot interpret them, you won't be able to form them. After this, we are forming algebraic equations. Okay, cool. Let's see. An unknown number, we have our M. I keep using yellow for unknown number. It's very weird. Cubed is to the power of 3 is the square root. So this dude over here is a square root of twice the unknown number. So twice the unknown number, so 2m increased by 3, which is our plus 3. Beautiful. Okay. Can we remember our rules again? Okay. We keep the chat lesson related. Please respect each other. Okay. This one feels too easy, but we can do it anyway. I saw someone's hand go up. Tabi Singh, are you going to do this one with me? Tabi Singh. It's okay. Welcome. Okay, Tabi Singh is not unmuting. Mamelo.
Hi, ma'am.
Hello, you're going to do this one with me.
Yes, ma'am.
Let's hear.
So, ma'am, it's a square root of an unknown number decreased by 4.
Decreased by 4
equals to 3 times a known number.
Okay. The square root, I'm not sure what I wrote there. So the square root of an unknown number decreased by 4 equals to 3 times the unknown number. So you see here, guys, the fact that you used the tells us that it's the same unknown number. She didn't say it's 3 times a unknown number. They said 3 times the unknown number. Okay, thank you, Mamelo.
Okay, ma'am.
Apedi, are you ready? I think we can move a bit faster now. Apedi, let's see what's next.
Yes, ma'am. I was asking a question, like instead of us using plus, we used increased.
Yes, that's all we're doing. But remember, you don't have to use those. Okay, there's a reason we had this table at the beginning here. You see, so we could
Yes,
say those two things combined, or we can say this is more than, or the sum of, or all together. So that's the reason I gave you this vocabulary. Okay,
yes, ma'am.
as long as what you're writing down makes sense. Okay, that's fine. Let me find someone else who's gonna do this with me. Nope, never mind. Everybody vanished. Let's do this one. So in this case, we're talking about ages. Maybe I should write that down and then everyone will vanish and panic. Ages. So I want you guys to tell me, how does Anne's age relate to Jane's age? Tato,
Yes, ma'am.
you want to do this one with me?
I can try, ma'am.
Okay, let's hear.
So, ma'am, you'd say twice the age of N
Twice the age of Anne
decreased by 8
by 8
equals Jane's age increased by 10.
Thank you. Thank you very much. That was easy. Okay, now we're getting closer to what we're actually going to be doing. Yes, interpreting means saying it in words. That's exactly what it is. Simple and straightforward. Okay. Now, I need someone to tell me. This is our final one. Of course, I wasn't going to be too easy on you guys. I need someone who's going to tell me about this. Oh, someone said, may I please scroll up. Mudiekhi, how far up, my darling? Raise your hand so that I know how far up you need me to scroll. Let's see. Guys, if your hand is up, I'm assuming you're going to answer this with me. Okay. So I'm going to lower all hands. And if you want to answer, raise up your hand now. Okay, hands just went up. The one we just did, please go up. Okay. I'm not sure. I'm going to leave these two up for a few seconds so you guys can take screenshots. If you don't know how to screenshot using a laptop, just press PRTSC and then go to any Word document and paste. So you right click paste, okay? Okay, I think we should be done by now. Mamelo's hand is up. Mamelo, are you ready?
Yes, ma'am.
Let's go for it.
So, ma'am, we're going to say cube root
The cube root
of an apple.
of, okay, A is the number of apples, okay? So the cube root of the number of apples.
Plus 55.
Avoid using plus. What other words can we use besides plus?
Increased.
Okay. Increased by 55. 55.
Then decreased by 8.
Do you say then decreased by 8? Mm-hmm.
Then we say equals to
Avoid using equals. Remember, I don't want you to just tell me what you see. I need you to interpret what it means.
of.
Okay, you can say, okay, it's fine. Let me just say equals. We'll use different interpretations as well. Equals.
Banana squared.
The number of bananas squared
By 9.
by 9. There's something missing there. Divided by 9. Mm-hmm.
Then decreased by 10.
Oh, I was tempted to write the word 10. Okay, let's check what we have here. So we have the square root of the number of apples increased by 55, then decreased by 8, equals the number of bananas squared divided by 9, then increased by 10. So because of this 10, then, you know that you decrease the 10 after you subtract. So I would suggest we do the same thing, because look at this. This then decreased by 8. Oh, but I get what you mean. No, it's fine. It's fine. If you wrote something different, like the square root, okay, no, I let's write it down. I saw someone say it in the chat. The cube root of the amount of apples, or the cube root of the sum of the apples and 55, decreased by 8 is equal to the square of the number of bananas divided by 9, or subtracting 10. Okay, guys, that was nice, né? I don't like plus because you're just telling me what you see. It's like saying 2x plus 5 equals, you know, that's not interpreting what we see. And now we have to form algebraic equations. And this was the whole point. So if you can't interpret them, you will not be able to form them. So Sarah is 8 years old. Thomas is 3 years older than Sarah, and David is twice as old as Sarah. The total of their ages is 51. Give me an algebraic equation that's going to represent this. Excuse me. Who's going to do this one with me? So first we have to figure out how old Thomas and David are in terms of x, because we don't know what x is. And then give me an algebraic equation that shows me that their total ages is 51. See, now we're doing quiet. Do you see why we were interpreting them? Because now we have to create them. Anyone want to do it with me? Come on, guys. There we go. Oh, I feel so much better. I'm just quiet. Caitlin.
Hi, ma'am.
Hello.
Okay, so with the sum, you would say Sarah's x is old, and you would write Thomas as x plus 3 because he's 3 years older than Sarah. Then with David, you would say he's 2x because he's twice as old as Sarah.
Okay, and then what's our equation?
It'll be x plus 3 plus 2x. No, sorry, ma'am. Plus 2x is equal to 51.
51. Okay, we have like terms on the side. Let's simplify. We're not solving for x, we're just simplifying. We have 1x, 1x, 2 x's. How many x's do we have?
We have 4x, ma'am.
There we go. So this can be rewritten as 4x plus 3 equals 51. Thank you very much, Caitlin. Okay, guys, let's check in. Let me check in. I haven't checked in today. Is everyone still with me after we just created that algebraic expression? Now we see the point of interpreting them because we have to create them. And if you don't understand what the words mean, then you're gonna get confused. Okay, I haven't seen any thumbs down so far, so we're just gonna move on. No, Kanya says no. Kanya, raise your hand. Kagelo, raise your hand. Let's talk about it. Fatima, everyone who's lost, just raise your hand so we can talk about it and clarify what went wrong. Anyone? Okay, I'll try to slow down a bit. Itumeleng, do you have a question?
Yes, ma'am.
Let's hear.
On x plus 3 plus 2x, I was lost there.
Okay, so after we establish the ages, you see the last line says the total. What does total mean?
Equal to.
Okay, but what are we doing before that equals to? So if I say that the total number of bananas I have, what would I have done? I would have added them, right?
Yes, ma'am.
Yes. So do you see why we're adding? We have
Oh, yeah.
Sarah's age. Yeah.
Okay.
So we have Sarah's age, Thomas's age, David's age. And then it says the total, so we add them, the total of these ages is 51.
Okay.
There we go. Do you get
Oh,
it?
yes, ma'am.
Beautiful.
Thank you.
You're welcome. Nobody else is asking questions, and I saw people who said they don't understand. So I don't know. Nope. Anyone? We had to first interpret, guys. Some of you might find this easy, but some of you, yeah. Fatima, I can't go to the start, unfortunately. We are more than halfway through the lesson. You'll have to look at the lesson when we upload it on the video, okay? Mayenziwe?
Ma'am, please can you re-explain the question?
Okay, where did we lose you? Let's read it slowly. Sarah is X years old. You with me?
Yes, ma'am.
So I wrote X there next to Sarah. That's her age.
Yes.
Then it says Thomas is 3 years older than Sarah.
Yeah.
That's where the X plus 3 comes from.
Oh, yeah, ma'am. That's where I got lost.
Yeah, because when you say, if I say to you, you are 5 years older than your sibling, you're going to take your age, whatever it is, and you're going to add 5.
Yes,
You
ma'am.
see?
Yes, ma'am.
So that's
Yes,
what
ma'am.
And then the last one said Davis is twice as old as Sarah. So you take Sarah's age times 2. That's what twice means.
Yes, ma'am.
Yeah. And then at the end, it just says the total of their ages is 51. So all of their ages combined is equal to 51.
Yes, ma'am.
Beautiful.
Thank you.
You're welcome. Okay. Nobody else is raising their hand, so we're good. Let's see what the next one says. Jack has some sweets. Jack is going to be my friend, and I'm guessing Tato wants to help me with this one. Tato,
Hi, ma'am.
are you helping me with this one?
Yes, ma'am.
Okay. Jack has some sweets. Sam has 4 more sweets than Jack, and Brody has twice as many sweets as Sam. Altogether, they have 56 sweets. How many sweets? Okay, no, we don't want the how many. That is next week's lesson. We just want a algebraic expression that is going to represent this information. This is not today's lesson. Okay, let's hear what you got.
So, ma'am, Jack has some sweets, so we'll use Y.
Okay. So Jack has one.
And then Sam has Y plus 4 sweets.
Okay, Y plus 4 is Sam.
And then Brody has twice as many sweets as Sam. So, ma'am, would say 2 into Y plus 4.
So what do I write here?
It will be a bracket, open bracket.
There we go, Tato.
Y
You
plus
created
4.
this now, Tato. We have to write brackets so that you make sure that you distribute that 2, and this is Brody. So give me an expression to represent their ages. I mean their
Y.
sweets.
Oh, okay.
Mhm.
Y plus 4
Mhm.
plus 2 into Y plus 4 equals 56.
Can we simplify this expression?
Yes, ma'am, we can. We can say 2Y plus 4 equals 2Y
What's happening
plus
here?
4. So, ma'am, if we were to
What's
simplify,
happening here?
we need to distribute. So we'd say
There we
2Y
go.
plus
So
8.
distribute there. So let's leave these the way they are. So it's going to be 2y plus
8.
8 equals 56. Now add our like terms.
It's going to be 4Y plus 12.
4y plus 12 equals
56.
56. Beautiful. Thank you very much, Sato. That was brilliant.
Thank you, ma'am.
Okay, guys, another check-in. Are we good? Did I lose anyone? Did I lose anyone? Someone says yes. I'm not sure if that yes means I lost you or if that yes means we are good. Spoguhle? Spoguhle, your hand is up. Follow, put your hand up so we can talk about where I lost you. No. Okay, Spoguhle is not responding at this moment. Let's see whose hand just went. Okay, there we go.
Hey, ma'am.
Hello.
Ma'am, can you please re-explain the question? I'm lost.
You need to be specific, darling. Where did we lose you?
By the time she said, why did we use Y instead of X?
It doesn't matter which one you used. When you hear when I said we can use any variable.
No.
So remember, we can use any variable. So if you used X, that's fine. You could have used A for age, that's fine. You could have used M or Y or B, that's fine. Is that what's lost you?
Yes.
So besides that, do you understand what's going on? Hello? No? Okay. Let's hear what Follow's question is. Follow?
Hi, ma'am.
Hello.
I got lost when you started using the brackets, and I got lost when there were 2 Y's, and yeah, that's where I got lost.
Okay, look at this. So it says, we started at Jack, right? Jack has some sweets, right?
Yes.
So we chose to make those sweets Y. And then it says Sam has 4 more than Jack. So Sam has that Y plus 4, right?
Yes.
And then it says
Yes.
Brody has twice as many as Sam. So if Sam has Y plus 4, then Brody has 2 times Y plus 4.
Oh, okay.
Do you see why we had to use brackets? So it's not 2
Yes.
times Y, it's 2 times all of what Sam has, which is Y plus 4. That's why we used brackets.
Oh, okay. Thank you, ma'am.
And then here there are 2 Y's. We just added these. After we established how many sweets everybody has, we added them. But when you hear when we're doing algebraic expressions, you remember the
Yes.
distributive law? That's why we distributed this. We said 2 times Y, that gave us 2Y, and 2 times 4, that gave us 8. So are you fine now?
Yes, ma'am.
Beautiful. Okay, Rasejo, do you have a question? Lwandle, you need to put your hand up and tell me where I lost you. Why is it 12? Says Tato, because we added like terms. There's a 4 there and there's an 8 there. What's 4 plus 8? Yes, Rasefo. It's definitely not 10.
I'm a bit late, so I don't understand.
Okay, unfortunately, I can't start because we're 40 minutes in. You're going to have to watch this lesson again, okay?
Yeah,
For
I'm
now,
saying
just try and
question.
follow. Hmm?
This question, ma'am, could you please explain?
Okay, where did I specifically lose you, Rasefo?
In the beginning.
Rasefo, you can't miss the whole question. Listen, okay, guys, this is the last time I'm read the question. It says Jack has sweets. We don't know how many there are, right?
Yes.
So we chose to use Y. You could have used X for an unknown or A or M, but we chose to use Y, okay? And then it says, Sam has 4 more sweets than Jack. So if Jack has Y, Sam has Y plus 4. You see?
Yeah.
And then it says Brody has twice as much as Sam. So if Sam has Y plus 4, this whole expression, then Brody has 2 times that whole expression, which was Y plus 4. Are you with me?
Yes.
So then it says, altogether they have 56 sweets. So we just added them and put it equal 56, and then we simplified, okay?
Mm-hmm.
That is it.
Okay, thank you.
You're welcome. I saw someone said, why did we use brackets with Brody at Y plus 4? Because if you don't use brackets, look what happens. You're going to say 2 times Y plus 4. Then you're only going to multiply the Y, and you're not going to multiply the 4. So you're going to have 2Y plus 4, which is incorrect because it should be 2Y plus 8. Okay. Blondie, I hope you see why we use brackets. If you don't use brackets, you're only going to multiply with the Y, and we want you to multiply with everything inside the brackets. Okay. All right. That's cool. Let's see what else we have. We still have a brain break, and we still have so many more of these to go after the brain break. Let's do a brain break. There we go. We deserve a brain break. That was a lot of explaining and understanding. Let's see. Would you rather fight 1 horse-sized duck or 100 duck-sized horses?
I would rather fight a 1 horse-sized duck.
So you'd rather fight a massive duck?
Yes.
I would never. I would rather fight 100 tiny horses, guys. I can't fight like our guys.
You never finish.
Do you know how destructive ducks are? Imagine if it's as big as a horse. Hi guys. I'd rather fight 100.
I see that everyone is agreeing with me to fight 1 horse-sized.
You spoke too soon, ma'am. Just look at the
I
messages.
see. As soon as I said it, then the answers come.
Yeah, no,
100 of them. Where are you gonna go with 100 little horses chasing you?
At least they're little.
But
Okay.
ducks aren't that little.
Yeah, but they're not as big as horses. Imagine fighting no, I can't do it. And then they pick in your house and they ruin everything, and Yep. I can't, guys. I can't. Let's see what the next one is. Would you rather have your ringtone be someone screaming or someone crying? Narisha.
Hi, ma'am.
Hello.
I would have crying. Someone's crying.
I know. I would rather also have cry. I would rather have cry, guys. Imagine screaming Velo screaming will also scare you while you're chilling there, and suddenly it's like, ah, and you're like, what? And then you remember it's your ringtone, and you're like, oh, sorry, everyone. Nothing's wrong. I would rather have crying, guys. In the middle of the night, I feel like both would be creepy. Because why are you screaming in the middle of the night? But also, why are you crying in the middle of the night?
It wouldn't be my, ma'am. It wouldn't be my crying though.
Yeah, that's fine, but it's better than screaming, guys. Imagine, guys, you know, if you're in like a taxi, everyone's gonna run out. And they're gonna follow you because why did you make us all run out? So please make wise decisions, guys. Please make wise decisions. Let's hear what Mabel has to say. No, Amahle, you have to choose one. You can't put it on vibrate. Would you rather only take 4-hour baths or only take cold showers? Let's hear.
4 hours bath.
4 guys, you're gonna come out like a wrinkled sausage. Your skin will be, guys. Also, you're wasting time. Where do you find 4 hours in a day to bath? No ways. No ways, guys. You're gonna spend 4 hours of your time in a bathtub. Never days. I would rather take cold showers. Yeah, I'd rather take cold showers. I haven't stop it. I would rather take cold showers, guys. Just you'll be strong, guys. You'll be strong. Exactly. I see a lot of people are saying cold shower. And if there's no chilling, you can still shower. You won't even care. You'll just keep showering anyway. We're used to it, guys. We're used to it. 4-hour baths are a waste of time. Let's see what's next. Would you rather only eat food that is too salty or food that has no flavor at all? Let's see what you guys have to say. Abisha? Abisha? Oh, I can't hear you. I can see you unmuted though. People say salty. Guys, you know salt will kill you. Who says I don't care? I'll just eat it. Guys, think of eating pap or something, but my pap has flavor. I don't know about y'all. Luvo? Is it Luvo? Luvo, what would you rather eat? Luvo's also not unmuting. Amahle. No, imagine eating chicken. Oh. Guys, do you know?
I choose salty because like my sister already cooks like salty food, so I'm used to it.
I can't believe it. You know you'll be sick. Like your body won't even absorb water. That water will just pass.
Man, it's better than just eating plain food.
Nah, I would rather eat no flavor. It's like eating, some of you guys eat salads anyway, so I don't know what's the problem. Guys, you know a salad once made me sick, but that's a story for another day. Okay, let's see. Stop laughing. I'm actually, guys, salads make me sick just based on the fact that there's so much lettuce. That makes me sick. Bombastic side eye. Would you rather use lotion as toothpaste or toothpaste as lotion? Tegan, let's hear. Like boiled chicken, guys, no flavor. Tegan, are you there? Yep. There we go.
Ma'am.
I
would rather use lotion as toothpaste, ma'am.
Oh. You're gonna
ma'am,
but
ma'am, hear me out. Think about it. You spread toothpaste all over your body, wasting it, then you become blue, all that color. Going out, man.
Think of that. Guys, you become blue.
That's what I was saying?
I can't believe it. But guys, you know those Nivea lotions, those really thick ones. You're gonna put it in your mouth. I can't, guys. I can't.
Yes.
Sorry. Mm-mm. I cannot. Then you become blue. I know that's what finished me as well. And that is all I have to say. Imagine Vaseline, guys. Okay, let me stop traumatizing you guys. We actually have work to do. Okay. I can't believe everyone would use lotion as toothpaste. You guys are traumatizing me. I actually can't with you guys. Okay. Now we're getting into some interesting stuff, right? Let me do this. We don't want the mass of each one. We just want to create an algebraic equation that represents this information. There we go. Okay, who's gonna do this one with me? We still have some time. At least you smell minty. Exactly, Kamukelo. Like I don't understand. Like with lavender, like can't actually can't. I'm gonna stop thinking about it. Who's gonna do this one with me, guys? Let's read it together. It says a biscuit barrel has 3 types of biscuit. Each jam ring has a mass of 5 grams, more than the mass of each lemon cream. Wafer sandwiches are twice as heavy as jam rings. There are 12 jam rings in the barrel, 5 lemon creams, and 32 biscuits all together. The total mass of the biscuits is 1,056 grams. Let us look for an equation. Where would you start, guys? Where would you start? Okay, Fatima. Back to the lesson, guys. Where would we start?
Ma'am,
Mm-hmm.
I would start by saying 5 grams.
Mm-hmm.
Ne. Then as we were saying the numbers, we're not putting it in we're not interpreting it in algebraic equation.
We're writing an equation. So here we have lemon cream. We have to figure out how many biscuits we have of each. So we have lemon creams, jam rings, and the third one is what? Wafer sandwiches. So I'm just gonna write wafer. So we have to find out how many of each we have. Chief says x cubed. I'm not sure where the cube comes from. So it says, nobody's doing this with me. Okay, let me show you guys. Okay. Yes. Fatima, you were saying something? No? Okay. Okay. So let's start here. It says each jam ring has a mass of 5 grams more than the mass of each lemon cream. What does more than mean? What does more than mean? I need you guys to see that you can do this. I'm pushing you guys a little bit. You should be able to do this. Thank you, Mamelo. It is a plus, okay? So it seems like we are starting from lemon creams because it's telling us it's this much more than lemon creams. And I'm gonna use yellow for lemon creams. So I'm gonna choose my lemon creams as X. So if my lemon creams are X, then the jam rings will be X plus 5. Are we with me? Did I lose anyone so far? Yes, Fatima, what do you have to say? Did I lose anyone so far? Nope. Okay, we're all very quiet. Where did I lose you? Okay, a lot of people are still with me. That's fine if you say that, Manelo. That's fine. Fatima? Guys, please tell me where I lost you.
Oh, yo, ma'am, yes, ma'am. As I was saying, you lost me at lemon cream and yeah, add more than the mass of each lemon cream. You lost me there.
Okay. So Fatima, choose a mass of lemon cream. I'm choosing X. Do you know what the mass is?
To say.
Okay. Do we know what the mass of the lemon cream is?
No, it's unknown basically.
So I chose a X. Are you with me? Okay.
Yes.
Then when you
So
read,
you can choose any variable, ma'am.
yes.
Yo,
Yes. Okay. So you can choose any variable. I feel like you might be having some connection issues, but yes, you can choose any variable. And I chose X. Okay. So this thing says a jam ring has a mass 5 grams more than, and you all told me that more than means plus. So it has 5 more than the lemon cream. So if the lemon cream was X, then this has to be X plus 5. Okay, that's all I did, guys. And then we move on and it says, the wafer sandwiches are twice as heavy as the jam rings. Tell me what twice means. When you see the word twice, what do we do in our equation? Thank you, Tammy. Twice means multiply by 2. What are we multiplying by 2? The whole mass of a jam ring, X plus 5. Beautiful. I'm stopping. Did I lose anyone? Hoping I didn't. Okay, I think from now on you'll just tell me because we're running out of time. So we have the mass of 1 of each biscuit. 1 lemon cream is X, 1 jam ring is X plus 5, and 1 wafer is 2 times X plus 5. Cool. And then we move on. There are 12 jam rings, 5 lemon creams, and 32 biscuits altogether. Okay? So there are 5 lemon creams. So if 1 lemon cream is X, then 5 of them is how much? If 1 lemon cream weighs X, then 5 of them weigh how much? Let's hear what you guys have to say. If 1 of them is X, thank you, guys. So in total, all of the lemon creams are 5X. I'm going to say LC. Okay, my L is horrific, but you guys get the point. We've dealt with lemon creams. But now they're telling us there are 12 jam rings. So we're going to say 12 times the weight of 1 jam ring, which was 12 plus 5. Okay, and then they say in total we have 32 biscuits. That means we need to figure out how many wafers we have. If we have 32 biscuits, but 5 of them are wafers, I mean, is it 5 of them? No, we're figuring out how many wafers. 5 of them are lemon creams, excuse me, and 12 of them are jam rings. How many of them are wafers? Let me know. We have 32 cookies in total. 5 of them are lemon cream. 12 of them are jam rings. So what is left? The ones that are left have to be wafers, guys. Do you see why I said we must follow the language? This is why there's a lot going on now. So it's 15. Amy, I'll take your question just now. So there are 15 wafers. So it's going to be 15 times all of this, 2x plus 5. I'm going to leave it here, and this is where we'll start in our next lesson. Bye, guys. Please do the poll. Do the poll. Next lesson, we're going to start here. If you feel like you can solve this, then solve it. Okay? Write down my expression. But yeah, if you feel like you just want to wait, then with this, we're going to start on Thursday. Yes, Chief, you have a question.
Hi, ma'am.
Hello.
I wanted to ask, how did you get 12 and 32?
Remember, we have to read. What does it say there? Where I circled. There
it's
are
12 gem rings.
And then here, what does it say?
32 biscuits all together.
You see now where I got them.
Okay, thank you, ma'am.